Hello and welcome to today's episode where I want to talk about the project we call Policy Weaver, which is there to synchronize data access policies from one data store to Microsoft Fabric. That means if you're integrating data to Microsoft Fabric via a variety of ways, which I showed in another video already, you might wonder, how can I replicate the data access policies I already set in this specific data source? Is there a way to kind of automatically bring that over? And the answer is yes, by the so-called project Policy Weaver. I was also engaged in the development of this project, so if you have any questions or feedback, also let me know. So what's the plan for today? I want to give you a quick introduction on what the idea of Policy Weaver is, how it actually works, and then today I will specifically show you in an example how to bring data access policies from Snowflake to Microsoft Fabric. So not only eventually see the same data in both engines, but actually apply the same kind of data access policies. So what's the idea of Policy Weaver? It's a solution to export data security policies from a variety of data sources, specifically like very popular ones like Databricks using Unity Catalog or Snowflake, BigQuery, and other ones, and use those data access policies and recreate them as OneLake Security roles within Microsoft Fabric's OneLake. Currently, the solution supports, I would say, like the most prominent examples. That's Azure Databricks Unity Catalog and Snowflake. So why do you want to do that? We typically get that asked to ensure this consistent security across data stores. Yeah, so you don't want to be logged in into one tool, but one kind of mechanism to be logged in is, or an argument is, okay, I only want to apply the logic of data access policies in one solution. I don't want to replicate that. It's too much effort. It's hard to get that in sync. That's why we have this automatic approach. It also reduces the risk of vulnerabilities, so making sure that you don't give too much privileges. It simplifies this whole management of security policies by being able to extract that in some kind of external storage, kind of abstracting that away, building a catalog of catalogs eventually. It reduces the human error by programmatically approaching that, also making sure to capture all the nuances in those security models. And it provides you like a quick inventory of all the data access policies defined in these environments. So how does it look like specifically? It's developed by Microsoft folks, but it's an open source project. You can just go to GitHub, you can download it, you can use it, you can look into this code, you can make suggestions how to improve it. It's a pluggable framework in that sense of it's kind of abstracting away how the policies look like. So it's kind of building a abstract policy export object. It's a Python library, and basically it can be run from anywhere where you have some Python runtime. So even like Fabric notebooks or Databricks notebooks or your local machine or some other kind of environment where you have a Python runtime. It can, as I said, it's pluggable, so you can build connectors to source systems and just, enhance the experience. It also has some features for traceability and the abilities to audit. So basically to kind of log which kind of actions have been done, which kind of policies have been added or removed. That's kind of the core functionality. So in a nutshell, you have all these kind of ways how to integrate data to Fabric via mirroring, shortcuts, using Data Factory, pushing data to OneLake, using partner solutions for data integration. To bring data from all these kind of data sources, specifically popular targets are Snowflake, Databricks, BigQuery, and what is missing is actually like this piece in the middle, to bring also all the permissions over, who kind of, which groups, which roles, which users have read permissions on specific tables, some kind of column level security which needs to be applied, row level security, all these kind of things. So that's not part of the raw data asset here, but it comes on a different stream. And that's basically covered by Policy Weaver to fill this gap. How do you run it? It's basically just installing the Python library using pip. Then you have some configuration which can be adjusted in a YAML file. It's in that sense, it's very easy to set up, and you can run it wherever you want. And you should find all the documentation in GitHub. If you have some kind of questions, give us feedback, let us know what is not understandable, where you need some more details. Happy to help you out there. And now I want to go into more details how this looks for Snowflake. I make another video for Databricks, but here Snowflake is our main actor here. So Snowflake is brought over to Fabric in a variety of ways nowadays. So a very popular approach was using is using the Snowflake mirroring. So basically connecting to a Snowflake database and selecting which kind of tables you want to bring over, and then you have this low latency incremental load of data directly in Fabric as a mirror database item. But as I said, you don't have the data access policies brought over, so you basically start from scratch. What Policy Weaver is doing, it's extracting all the users and roles and grants from Snowflake using the Snowflake account usage schema. It takes care of all the nuances, like if you kind of inherit some privileges via some direct or transitional role memberships. So it's making sure like what kind of privilege actually apply to each and every role, to each and every user, to each and every group. And also checks like if you also have all the prerequisites for reading a certain table. Yeah, so also having usage permission on the schema, on the database level. So this is all handled programmatically. It then builds this kind of generic agnostic policy export object, which then Policy Weaver has the plugin to apply this directly on Fabric and the OneLake security roles. So that's basically the process. And now let's jump in and look how this would look like directly in Fabric. So I will show the demo, and then I will go also in more details about column level security, row level security, and also how to configure it for your environment. So I'm starting here in my Snowflake environment. You see I have one database here, which is called pwdemo. I have a pw schema here, and I have a couple of tables within this schema. Based on kind of the names you might guess, I have different privileges. So I have like a sales role, which has select permissions. That means read permissions on this table. I have a more exclusive one where only like the role sales exclusive has access. I have a sales very exclusive table where the sales super exclusive role has select permissions. And then I also have for row level security, I have the sales RLS where everyone has read access, but I have some kind of row level security policy on top of it. And the same for sales CLS where I have everyone has select permissions, but I have some column level security policies or some masking policy on top of it. In the end, in each of those three roles, sales exclusive, sales super exclusive, I have a different users which have like login name with the email address, and that's how I identify which kind of users should have access in Fabric. So first of all, how do I get this data over? For that, I go into the Fabric workspace. I create a new item. I select my Snowflake mirror item, and I set up the connection. I'm reusing a connection here, which I've already set up. And then I can select which kind of database I want to mirror. So this PW demo looks pretty nice. And I basically select all the tables which I've just shown. I select these 5 tables here and click on connect. And then I create the mirror database. So this might take a few minutes, and then you already see these tables are being constantly mirrored to this mirror database item. Next, I want to see which kind of OneLake security applies. At the point of time of this video, you actually have to kind of enable this via some little hack here. So there's like this hidden flag here, which is called mirrored one security equals 1, which makes actually the OneLake security available for mirror database items. So this button now just showed up. So if I click on this, I actually confirm that I want to use OneLake security now for this item. With that being enabled, I can look at the roles and I see that indeed I have OneLake security here, but I only start with this default reader, which basically takes everyone who has reader access on the workspace level and gives him specific runs for that. But yeah, no one else has the access policies. So if I have like my setup on the Snowflake side, I actually want to bring that over. For this, I use policy Viva now. So how does this look like? To run this, I create a new notebook here within my workspace, give it a nice name here, and create it. What I need now is to install the Policy Viva library and upload a config file with all my configurations. To upload the config file, I go to resources here, built in, which allows me to upload some resources. These 2 files here, which I've uploaded, one is basically the YAML with all the configurations. The other one is actually the key, which I'm using for my key pair authentication. You find all the information here in the documentation, but later on I will also go into more details, how this config file looks like. So the code I need is basically just the pip install and then running this code. So you can find both commands here, pip install in the install section here specifically for Snowflake, how to run it with the Snowflake configuration, and that's basically it. So this will take a couple of seconds just to install the library, and then it will just run the sync process. So to see the OneLake security roles, I click here again, and I find I have 3 roles now. They have actually exactly the same names as my roles in Snowflake, so that's actually brought over directly. They just have like the suffix here, PW, just to distinguish, okay, if I create some new rules here on top of it, that I don't delete them via policy Viva. That's how I can identify them. So if we look now into one of these roles, the sales role here, what kind of scope does it have? Okay, it has read permissions on the sales table and read permissions on the sales CLS table, but with some kind of constraints here. It says I have some column level security constraints. If you look at that, I see there are only a couple of columns. Specifically, there's a column mask, which I can show later on the customer column. And so it is hidden for that sales role. I also have the members here. So I see, okay, all these different people here, they all have are part of this role. So either directly in Snowflake or indirectly in OneLake Security, they have to be explicitly mentioned here, as there is no inherited of roles, no kind of roles can be added to this role, granted the privilege of a specific role. So that's why you see all the users here. For sales exclusive, I also see that there are only like those 2 people here, and it has specifically permissions on the sales exclusive table and specific, a row level security applied here. So actually this row level security policy, which I have on the Snowflake side, it prevents basically all the access for the sales roles. It limits the view for the sales exclusive role, and it provides full access to the sales super exclusive role. And that's why you see I have full access to this row level security. I have full access to this column level security, and I also have access to the sales very exclusive table here. And I see only this one member is mentioned here as part of this role. To check that, we can look now into the Snowflake side. On the Snowflake side, I showed you already how the table permissions look like, but for like the column level security, the masking policies, you can see there are some masking policies here. One which is actually relevant for us is that one here, which says if the role which is accessing the table is it is a list of roles here with one value here, say it's super exclusive, then it should see like the value, else it would be masked. And this is identified by policy viewer, which means this specific role should see the column. For each other role, it will block that column in OneLake Security. If we look at the row level security, that means the row access policies, we see it's also applied to a specific table here. And the policy body looks like this. So the super exclusive role has the full access. If it's the sales excl role, it filters by this ID, and everyone else is denied. So this perfectly matches how the OneLake security roles are set up now. So with the conclusion of this demo, I will go into more details about how column level security and row level security matching is done, and go more deeper in how this config file needs to be set up. So when you think about column level security, it's handled a little bit different in those different platforms. So Databricks and Snowflake support column level security by column mask policies. On the other side, OneLake Security in Fabric only supports column level security by actually denying access to specific columns, or on the other side, allowing access to only those defined columns. I mean, I would say like 95% or even more cases, column mask policies are actually used exactly to deny access to a column, not so much on hiding just a specific part. So for these cases, we are well covered. So what is covered is if you have any kind of column level security in that kind of syntax here, so specifically for Snowflake, where you say a case when current role is in this list of roles, then show me the value, else deny it. Or the other way around, if you say I want to block it for a specific role and everyone else should see it. These kind of cases are supported and will end up directly as column denial workflow in OneLake Security. You have the option to configure a fallback. So if a policy viewer can't really identify or do an interpretation of this policy here, then it will go back to your fallback. So if you want to avoid to overshare data, to expose data to people who shouldn't have access, we highly recommend to set the default to fall back to deny and just block this column, because eventually you in OneLake security you can create an additional role which actually grants access. If all columns of a table are denied, so if you have like masking policies on all tables and for a specific role they should see nothing, then actually the whole table will just not show up in Fabric. So also role level security works a little bit different in these platforms. They support, all of them support row access policies to filter a table on a specific filter condition. The big difference is that Databricks and Snowflake are applying this on the table and not to a specific role at that point of time. In OneLake Security, you always apply it on a table, but in the context of a role. Yeah, so it's always a role table combination where you set a filter. The other platforms, it's kind of built into this policy that you differentiate. You set it on the table and that you specify in this policy for different roles, different filters apply. So these are kind of the policies which are supported for specifically for Snowflake. For Databricks, it looks pretty similar. So these kind of three variations here. When you have the statement of case, when current role is insensitive and true, that means this role sees everything. This role here has this filter applied, else so everyone else just see nothing in this table. You can have even more simpler statements, which basically say, if you're part of or have one of these roles, then you see everything, else you don't see anything. Here you also have the option to set a fallback. So here's the same. So if you have some kind of complex access policy, we will do the it's best to do an interpretation, but eventually if we can't do a good interpretation, it will fall back to the configured value. So we also recommend to set deny here so that you don't run into the risk of oversharing. Here it also applies that if you see that all rows are denied, so if this false is triggered for a no filter, then this whole table just doesn't show up in Fabric. So you don't see an empty table, you just see no table at all. And it's also the same for if all rows are allowed. So if you end up with like this true filter, which says, okay, basically no filter at all, then we don't build an additional filter in Fabric because that would just bring in some performance issues. So we just leave the filter because it doesn't have an effect. With that being said, now let's see more into details how this config file will look like. Config file has several sections here. The most important ones are here about Fabric, where you specify on which kind of item you want to apply those new OneLake security roles. The name here is a little bit misleading. It's actually the item ID of this object. It doesn't have to be necessarily a mirrored database or a mirrored Databricks Unity catalog. It can also be a lakehouse or any other item which supports OneLake security. We can always apply those roles there. So if you bring in the data via some other process, for example, to a lakehouse, you have the same schema, you have the same table names, then you can also use that. That's specifically interesting if you're shortcutting Snowflake iceberg tables or use other integration methods. So this still applies there. You have to specify the workspace ID and the tenant where you have those this Fabric item. The Fabric role suffix means what is kind of used to highlight which kind of roles, OneLake security roles have been created by Policy Weaver. That's also the kind of marker we use to delete old roles, to override them. We keep all the ones which doesn't have these suffix, as we recognize these are ones which have been manually added. We can also specify if you want to delete this default reader role which exists from the beginning. For policy mapping, we actually have two choices. One is table based, so table underscore based, which would mean we create a role for each kind of database or catalog level, schema level, table level. So the scope is actually only one of those tables or schemas, and then we just add all the principals who have access there. The more recommended way is actually role-based, where we match what is there in the source. So for Snowflake, it would be the Snowflake roles. For the constraints, you can specify columns, but also rows, which is not shown here, but in the documentation. For rows, it's the same here. For columns, you specify if you want to use it or not. And if so, what is kind of the fallback? The fallback means if we can't do an interpretation of the policy, which can be very arbitrary, if we can't do a matching of these policies, what it actually means, then this fallback applies. You need a service principal to apply the OneLake Security role. So the service principal needs permissions on this fabric item. This is mentioned in documentation. You specify if you only want to apply security roles, data access policies for specific items, so only specific schemas or specific tables. You specify which kind of source you want to get those data access policies. So this can be Snowflake or Unity Catalog. And then depending on what you're using, you have the credentials, how to connect to your account. So for Snowflake, you need the account name, the username. You can use username and passwords, but we recommend to use like key pair authentication, encrypted key pair authentication. So you have the username, the path where you have your private key, the passphrase of this private key file, and in Snowflake, you need to specify the warehouse which you want to use to run these queries against this Snowflake account usage schema. We have some keyword integration. That means you don't have to put all the credentials here directly in this config file. So these credentials here, they are covered also for the service principal, that they would be looked up in the key vault. If you want to use that, you specify here, I want to use the key vault, you give the name of the key vault, and then you say, okay, which kind of authentication method do you want to use to connect to the key vault? You have two options here. One is fabric_notebook, which means it would use the context of the user who's running the notebook. So the user is running the notebook, needs access to the key vault, and in the key vault you have all the other credentials. The other way is to use the Azure CLI. So it would be Azure_CLI. That would mean if you run it locally, you log in with the Azure CLI first and then run the code. Then it would use the user which you logged in via the Azure CLI to connect to the key vault, connect then the details and run it from there. This kind of gives you another layer of security of not putting those credentials directly in this config file which you upload. So that's basically it. If you have questions, if you want to provide feedback, just use this feedback forms here. The solution can be found in this GitHub repo. It basically looks like this. It gives you all the kind of documentation and explanations you need, how to get started, how to do the installation, specifically what you need to set up in any case, and then for Databricks and Snowflake, what you need to do. It also has some smaller demo videos, how it would look like, but you can also rewind this video here. It also links you or gives you more explanations on this config file values. And and if, as I mentioned before, if you run into some issues or wish for new features, or also let us know if you like it, what you don't like it, just use this feedback form and inform us about it. And if you like this video and want to see more content like this, then please like this video, subscribe to the channel, and happy for every feedback. Thanks. See you.